bottom part of our chassis, and we have connected a wheel to it which can rotate freely. This is the wheel which can rotate freely. These are the two DC gear motors which we are going to use in our project, and we will fix these two motors on the chassis with the help of these clamps and bolts. We put the clamp on this DC motor like this, and two holes are provided over here. We will place the bolt inside this and we'll simply push it. This is how the bolt has to be placed over here, and then we will put these two nuts over here in order to fix it properly. This is how this operation is done, and now we are done putting this clamp on this motor. The same process needs to be repeated for the second motor as well. Now we are done fixing this clamp on the motor, and now it's time for us to place this motor on the chassis, and we have to fix it over there. This is how we will fix this DC motor on this chassis. We'll put this clamp over here, and then we will put this bolt over here, and then the nut on the other side, and then we will tighten it, and like this we will be able to fix it like we have done in this case. As you can see, we have done like this. Just have a look at the reverse side. We have placed the nut over here and we have tightened it, and now finally we have fixed these two motors on this chassis quite firmly. This is our HC SR04 ultrasonic distance sensor, and we are going to fix this on the chassis with the help of these covers. First, we will place it over here like this, and then we will place the back cover like this, and we will put the bolt over here and we will tighten it. Now we have tightened up the screw, and now we can place the servo motor's blade at the bottom over here. This means at this place, so that its motion can be controlled accordingly. Now we have pasted this blade over here so that this will go to the servo motor, and its motion, when the servo motor will rotate according to the instruction given to it, then this ultrasonic sensor will also rotate. Then only we can sense the obstacle distances in different directions. This is SG90 micro servo motor which we are going to use in our project, and this servo motor is actually used to precisely control the motion of our ultrasonic distance sensor. This servo motor will be placed on the upper chassis board for better control. We put this cover first, and then only we will be able to fix this on the upper chassis board like this. We place it like this, and then we have to place the bolt like this, and we have to simply tighten it. After tightening this like this, our job is done. As we can see, the servo motor is firmly held over this chassis, and now it's time for us to place this ultrasonic sensor at the top of it. We will place it like this, and we will put a slight pressure so that it goes inside and it holds it firmly. And now finally our ultrasonic sensor is firmly held at the top of this servo motor. And now we will go to the next step. Now as we can see, this is the lower chassis and this is the upper chassis, and this upper chassis will be placed at the top of this lower chassis like this. But before that, we have to place the wheel to the bottom chassis. These are the two wheels. Now these wheels will be placed inside. These are the shafts. First shaft, this is the second shaft, and this shaft will get inside the hole which is provided in this wheel. We have to apply a slight pressure Finally our wheel is placed like this. We can have a look at it. And now we are going to place this upper part over here with the help of a bolt and nut. 4 bolts will be provided, one over here at the one at this corner, one at this corner, the second one at this corner, third at this corner, and the fourth one at this corner. With the help of a double side tape, we have placed one of the batteries over here and the other one over here. This is a DC battery cap which is placed at the top of the battery, which is connected to wires so that we can have it for connection. And over here, as we can see, we have attached this cap to a switch. This is a DC switch with the help of which we can switch the circuit either on or off. And now we have inserted this switch at the top of this upper chassis because there is a provision for it. And as we can see, this is how we have done it. This cap will be placed at the top of this battery, and similarly for the other battery also, and the other connections will be made accordingly. Okay, so this is our L298N DC motor driver. In order to make connections over here, we have to initially loosen up the screw, and then we place the jumper wires over here, the end of the jumper wires over here, and then we have to tighten up the screw. And there are 2 enable pins over here, and 2 jumpers were present. These are the 2 jumpers which were present at the top of it, and we place the jumpers only when we need to control the stepper motors, but since over here we are controlling 2 DC motors, so there is no need of it, and we will remove it. So now in order to make connections over here at this point, we have to use male to female jumper wires. Then only we can connect these points to the Arduino. So our connection has been made like this, and now the male end of this jumper wire, this male end of this jumper wire will go to the Arduino board, and it will be connected over there accordingly. Now we are going to make the connections for the DC motor. These 2 will control the motor A, and these 2 will control the motor B. We place the point here, and then we tighten up the screw. This is how the connection will be made. So now finally we are done making connections with this L298 and DC motor driver. Now we are going to place this DC motor driver over here, and now we have actually changed the position of this battery because as we can see there is not much space available on this chassis, so we have to do the planning quite wisely, otherwise we'll be running out of space at the end. This will be fixed over here with the help of a double side tape. Now the wires coming out from this point and this point will go to the motors. This one will drive the motor A. Let us consider this is the motor A, and then this one will drive the motor B. Then this will be the motor B. So we have to connect these wires to this point accordingly. Here there is a point, here there is a terminal. We have to connect that wire over here. Now we are going to place this cover at the top. This is the upper chassis. We are going to place it over here, and then with the help of these bolts, these are the bolts and nuts. With the help of these, we will fix it. One of the bolts will go over here, the second over here, third over here, and the fourth one over here. So in this way, we will formally fix it. Okay, so this is our breadboard. This is the breadboard. This is the push button. This is the push button. This is the resistor. This is the connecting wire, and these two are IC7805. The purpose of using these two is that we have to convert the 9 voltage power supply from the battery to 5 voltage, because the Arduino and these servo motors and ultrasonic sensors, they're all operated at 5 volts. So it is much better to convert it, otherwise it may happen that our product will get burned out. Now this breadboard comes with a double side tape at the bottom of it. One just needs to remove that sticker from there and simply place it at the top, and it will get firmly placed over here. So that's it. Finally, this is Arduino Uno, which we are going to use in our project, and this is actually a microcontroller which behaves as the brain of the entire circuit, and we are going to place it at the top of our chassis. For that purpose, obviously we need a double side tape at the bottom of it. We have to place the double side tape at the bottom of this Arduino board, and then it can be placed firmly at the top of our chassis. So now we are going to do it. This is the double side tape. We are going to cut some pieces of it and we'll place it at the bottom of this board. And finally we have placed this Arduino Uno at the top of our chassis. So we can have a look at the entire robot. It looks like this now. Now what we have to do is that we have to make the connections accordingly, according to how we have designed the circuit in Tinkercad. We are going to connect it accordingly. And after proper connections are made, we will require to upload the program code, the code which we have written in Arduino environment. We have to upload that in this Arduino board, and that uploading of program will be done by a USB cable which has been provided. Now we are going to upload the program which we have written in the Arduino platform, and that program will be uploaded in this Arduino board with the help of this cable, this USB cable. This part will go into the USB port of the desktop, and from there we can simply upload the program. This Arduino has been connected to the USB port of the computer, and now the uploading process is going on. And finally the uploading is done. Now we are going to make all the connections in this breadboard. As we can see, these two wires are actually the connection for the power pins that is provided in the motor driver. Then we have these 6. These are actually the combination of enable pins and the input pins for the motor driver. And these enable pins and input pins of the motor driver will actually be connected to the Arduino board accordingly. Some of them will go to the PWM pins and some of them will go to the digital pins as our requirement is. And this entire circuit is made by considering what we have designed in Tinkercad. For now we have successfully made the connection for the motor driver, then servo motor, and now it's time for us to make the connection for this ultrasonic sensor. For making connection of this ultrasonic sensor, we need to use male to female jumper wires, and then it can be easily connected to the breadboard and the Arduino as the case may be. Okay, so this is the board which will serve our purpose as an obstacle, and we will be placing this board frequently in the path of the robot while it will be moving to see the behavior of the robot. We'll see how it behaves, because it must avoid colliding with it. Because that is the purpose, that is the main purpose of a robot. And now it's time for us to see the final working of a robot. So let us go ahead.